Welcome to this new section on data. The dataset we shall be working with is a Pascal VOC 2012 dataset, which can be downloaded via this link. The Pascal VOC project provides standardized image datasets for object classification recognition, common set of tools for accessing the data sets and annotations, enables evaluation and comparison of different methods, and also this project ran challenges evaluating performance on object class recognition from 2005 to 2012. Now it's finished. So here we go, we have the different challenges. Click on this 2012 challenge. As you could see right here, we have some sample images. Now for these images we have 20 classes. So when given an image, like let's zoom this, take this off. When given an image like say this one right here, for example, or let's take this one. When given an image of this bicycle, in fact the image could have many more objects, like this, for example, like this, where we have two objects. This, we have actually many objects. This too, we have two objects. So when given say this kind of image, these objects could belong to one of 20 classes, and these classes happen to be person, bird, cat, cow, dog, horse, sheep, airplane, bicycle, boat, bus, car, motorbike, train, bottle, chair, dining table, potted plant, sofa, and TV or monitor or computer monitor. After downloading the images, we should have something like this. Now let's open this. We have this image. Let's take this image we had used on the slides. That was the one we used to describe the object detection task, which was this. So let's open this. Okay, so this is the image we used. Now when we look at this image, let's increase this. Okay, that's fine. Now when we look at this image, we could see the person, aeroplane, car, some houses, and a car. But recall that there's no houses in the Pascal VOC dataset, so we wouldn't consider houses right here. So the model is going to be trained not to, or the model will ignore actually those houses since it's not in part of the database or the dataset. Now for each of these images, they actually a corresponding XML file which defines exactly what objects we are dealing with and where they are located. Now we open up the XML file which corresponds to that image, and here is the XML file we obtain. We have this folder, the file name, as you could see. We have the source information, we have the owner information, then we have the image size. So we have the width 500, height 281, as you could see right here, whether segmented or not. And then here comes the point where we start giving out information about the object. So in this object tag right here, this tag, so basically this is an object tag, this other object tag to give us information about all the objects present in the image. So let's start back from this. So right here we have this aeroplane. Next we have an aeroplane. Obviously we have two airplanes, so we have this and this. And then next we have a person. Next we have a person, and that's it. Okay, so let's get back to the top. We have the aeroplane. Let's take this. Okay, we have this first aeroplane. Now the pose, frontal pose, like we see this is an aeroplane. The pose is left pose, as you can see right here. This truncated or not, difficult or not. And then we have now the bounding box information. So right here we have the x mean 104. Now let's go ahead. 104.78 actually is this. So if we take this at 104, notice that this coordinates are given right here, so we could take that. So from this we have 104 and 78. We could reduce, go down a bit. We have this, so let's take this. Okay, 104, here we go, something like that. Okay, so we are on this. Now let's take the select, or is it select? Take this. We have this. Oh, we could just draw this out as a rectangle. We have the 104 that we've noted it right here. So we had 104, 78, and then we have 375, 183. Come to 375, 183. Look at it this way, around this. So we found around this. Now we could take this like this, draw that. Now let's reduce the size. Okay, so that's fine. So this is exactly the information we get from the XML file. So this is the kind of information we get. Let's try to see. We could change that from this. Oh, we've drawn it already, so it's not going to change. Now, so we have this information. Now let's take another example. The next example we shall try with a person. So let's take this person. Let's go to X main 26, Y main 189. Now note that this is the origin actually. So we're going 26 steps. Now we could look at this actually from here. We see how this is changing down here. So the X coordinate is changing while the Y coordinate remains intact. We go 26 steps, and then we move now 189 steps in the Y direction. So 189, we are around this 189, go down, 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 we are around this 189 is here. Now we'll go back 26, so we are that. Okay, so around this. So if we do this, we have this now. We have something like this. Now we just completed it right here. If we look at this point, we are at the point 48,236. So that's almost the same as this. So that's how we extract the information, or that's how this information of the bounding boxes is given to us in this XML files. Now the next point is supposing we have another object we want to detect, but which doesn't come with a Pascal VOC dataset, or supposing we don't want to work with a Pascal VOC dataset at all. So maybe we want to detect some cells and some medical image, and we want to detect the location of some particular cells in that image. Obviously, we wouldn't need images of aeroplanes or persons or whatever, because here we're dealing with maybe some medical images. So in that case, we may not, or we will not actually need any of those classes. Now we shall look at a tool which will permit us actually create our data set, which will get the same structure like the Pascal VOC dataset, such that we could use the same code or similar code, which we shall use in training a model which uses this dataset to replicate when we have a new problem to solve. A great tool which permits us manage or create this custom image data sets for our detection is the Remo.ai. So this helps us manage from here. How do you manage your image data set? You have thousands of images and 10 times as many annotations. Organize, annotate, and visualize. So this is Remo.ai for you. Yeah, you could visualize your data set, annotate. As you could see right here, we could also have the local installation, which we shall do shortly. The pricing is free for community, and then paid for teams. So we have that and this. Okay, let's go ahead and get Remo. That's free. We have this. This is a demo of how it works. Now let's look at this quick installation. Here we have pip install Remo, this command, and then we can launch it from here. So we just simply follow this tutorial, which they make readily available for us. So basically with this, after following this tutorial and then launching from here, we have the Remo app which is running, as we could see right here. And then here we could now actually see our Remo app. We could now create a data set. As you could see, let's create a gun data set. Gun data set, create that. That's fine. Get into this, we could add the data. So we could simply add data from this. Add images only, add image annotation. So we're gonna add images only. We come to browse files. Here we are. Select this. That's fine. Let's take this off, and then we could upload. Now we have these two images uploaded. We could have annotate. Obviously, right here we could add more data. So we'll go straight to annotation. We have this. We'll select the task. That's object detection. Type the name of the annotation set. Gun annotations, gun annotations. Okay, so let's now add some classes. So in here we have a gun, add that. We have also a person, because it's true we're trying to create a data set for guns, but it happens that most times when we have guns and images, the guns are held by a person. So that's what we have. Create that. So from here we go now to annotate. We select this, draw box. We have this. Now we pick this up. Yes, the gun starts from this point right down to this. We pick it up like this, and that's fine. So this is a gun. We have a gun, and then we save it. Then next we move to the next, where we have this person. So we could have this, and then for now we could always take this off so that it doesn't disturb when we try to do the next or annotate the next object, which is this person. So now with the person we have this, take from here and then up to this. So there we go. So now this is the person, and then we'll save that. So that's fine for this. We've had our two objects. Take this, could take this off, take this, and that's it. So we could enable the two views. We have the person, and then we have the gun. Now this is done. So, and you could always put the order on hold. So that's it. Now we have the classes. We could add a class, because this actually, we see that we have a dog. So let's have this dog right here. We add that. So we have a dog now. We go ahead to annotate the gun. We have this gun. That's fine. We have a gun. We save that. Put it out. Next we have the person. Take this from here. Start from up this way. Delete that. Take this from here. Now up to this level. So there we go. Person, we save. Put this out, and then lastly the dog. Take the drawing tool. We have this up to this, and then we have the dog. So we save that. So once we save that, we could now have that as done. And obviously we could go back to the other image. We could come back to this one. Then you could export the annotations for the data set. So let's look at this. We then select the remote JSON output, then we export it. Once that is done, we could download it from here. Let's open this. We'll see clearly our output JSON file with the images and the annotations. Right here we have the first image, this one, and then followed by this image. And that's it. So we have these two images. Then for this image we have the three different objects. That's the dog, the person, the gun, and their respective locations. But this output from the Remote.ai platform isn't exactly the same as what we need for the Pascal VOC dataset, where we're working with XML files. Now we'll see obviously that we have some similarities, as we have the bounding box, we have the class, like right here we have the class. This is person, for example. So where we have person, here we have person, we have the bounding box, we have also the bounding box right here, and then we have the class. So okay, we've seen the class already. Next we have the height, the image height, which is this. We have the image width, which is this. The depth 3. No need to actually specify that right here. That's why this wasn't generated by this platform, and that's it. So, and also we have the file name. So this too is important. So we have the file name because each image is going to be linked to this via this file name. So basically that's what we have. So this means that every time we working with this Remote.ai, we generate this, and then we shall write a code to help us convert from this to this form. Now note that for each of these images we are going to generate a separate XML file, because actually for each image we have a separate XML file according to the way the Pascal VOC dataset is structured. So for each of this, that's for this first one, for this first image, we have a file. Next one, we have a file, and the other we have a file. So basically, we shall create 2 files in this case, for example. Now the next thing we shall do is, once we've generated this automatically via the platform, we shall extract information which is in this JSON file. So like here, we open this file, we've changed the name from guns, or rather gun anno this, to guns.json. So it's basically the same file we're dealing with. We load it using the JSON module. We have we are going to go through each of these images via the for loop, which actually goes from 0 to the length of data. So let's print out data. Actually, we could print out data. Let's do that right here. Let's comment this for now. Print out data. We have this. So that's it. So this is what we have in the JSON file. Now we could count the number of images we're dealing with. Running this gives us 2 images. Now if we now go for this, so for each and every one of the images, we have the boxes. That's for each images we have the boxes, and then we have the classes. And then for each image we have also, for every object, its own particular box and its own class. And then the image has a width, a height, and a file name. So we could take this and put before. So yeah, the image has this width, height, file name, which we get from the JSON file. Now note that this JSON, the load converts the JSON into a Python dictionary. So here we're dealing with a dictionary. So right here we're able to get the width, here we get the height, here we get the file name, and then we remove the extension with this. Now we get into this part where we have to collect the bounding box for each object. And we have right here data. That's, we convert everything into a string. So we have the data, we select the image because the I goes for all the images. So we select the image. We're dealing with annotations. We select the particular object. We now have the bounding box. That's this. We now have the X mean. So the first is the X mean, which is basically this. The next is the Y mean, which is this. The next X max, and the next Y max. Now recall that we're using this because this is the same way it's presented in the Pascal VOC Dataset, where we have X mean, Y mean, X max, Y max. And then for each class, we select the image annotations, we select the objects, we have classes. That's basically this. And then we take the first value, which is in this case, for example, person. Here is gun, here is dog. So once this is done, we're now ready to pass it into this function, which collects all this information and is able to convert it into an XML file. Now notice how for each of this we have, or we generate an XML file, and that's what we basically do for each and every one of the images. Now note that we had used this JSON package, and also we are going to use the elementary package for dealing with XML files. The JSON was used right here where we loaded this file. Now for this elementary package, we'll define it as ET. So everywhere I see ET, we are basically using this package. Now on this, we collect the image width, the image height, and then the image file name with the boxes and the classes. And recall that this is just for one image, so we're repeating this 2 times in this case. So right here we have the annotations, which is this annotation. It's just some way of defining or some way of structuring our data in the XML file. And the way we could look at it is very simple. So right here we have et.element, we create an element and we call it annotation. So because in the XML or in the Pascal VOC dataset we have this, so that's why we call it annotation. So it's basically gotten from this. So we have this annotation, and you'll notice that once you define like this, you're gonna have this ending tag or this closing tag for the annotation. So that's it. We open and close, and then in here we have this file name, which is a sub element of this element annotation. And you could see from here file name. We've taken this off because this is not going to be useful in training our model, so taking that off, although you could always put it in if you want. So we have this file name right here, which is this, gotten from the JSON file. We have the file name and image file name, clear from here, we got it from this image file name, and recall that as a sub element of annotation. So that's why you see this, you see, gets into this annotation tag. So that's file name, and then in the file name we are going to put in a text, which is the image file name, obviously. So that's it. So that's how that works. But since before passing it into this we had taken off the extension, we should actually add it right here. So we could have this plus.gpg, or better still, since we could have many different types of extensions, we could take this, we'll let it that way. And then, because at the end, the reason why I would chop that off because we're going to use the same name and then create this XML file. So that's why we had to remove the extension. So what we could do is we could instead remove this extension before this. So we have file name equals image file name, like this, and then we take off the extension. Now the reason why we're doing this, we could take an example. We suppose we have a string, let's call it st, which is image.gpg, for example. If we do st and then we chop off the last 4 values, to see we have image. So that's basically the reason why we're doing that. So right here we'll chop this off before creating this XML file. So we're not going to do that again right here. So let's take this off. So that's fine. So with this, now we don't need to actually declare the or specify the file name right here, since the files may take different extensions. So once we are done with that, we can now move to the size. As you can see right here, we have this size tag, and in the size tag we have the width tag, the height tag, and then the depth tag. So we create this size, which is a sub element again of annotation. So the file name is a sub element of the parent annotation, so this is a child of annotation, and the size too is a child of annotation, because the file name and the size, they're actually on the same level. So with this we have the size, we have the sub element this with this name, and then we create now the width. The width is a sub element of the size, so the width is a child of the size, while the size is a child of the annotation. So the width is a sub element of this, so we have the width, and then the text we put in is the width we get from the JSON file right here. This is the image width. We do the same for the height and the same for the depth. So that's it for this part. So once we're done with this, now we could get into this, the objects. So again, here we have this object, which is a sub element of annotation, because this object is a child of annotation. Once we have that, we now go into the sub elements. We have the first sub element, which is the name. See here the name, which is actually the class. So we have this, and we send this to lower, because what is generated by the Remote.ai platform has an uppercase for the first letter, so we have to always convert that to lower to match with what we have with the Pascal VOC dataset. So once we have the right, we go to the next. We have this bounding box. This is this right here. We we not need this, we not need this, we don't need the post, we just need the name, and we need the bounding box. So we have the bounding box, which is a child of the object. So we have bounding box, child of object, that bounding box. Then we have now x mean, x y mean, x max, y max, which are children of the bounding box. So basically that's what we do. And then since we have the boxes from the JSON file, we simply have the zeroed value, the first, second, and third value. Now once this is done, we have the output, which is this element3.toString of the annotation. That's from here, right from here. So it's going to take all the, since this is a parent, it's going to take all its children and then wrap this up into this element3 object we have right here. Then we have the image file name. We've seen this already. We open this file, or we open this, we open this file. Notice that we have the image file name.xml right here, and then we write into it. So let's run this, run it. Now opening this annotations folder, we have the gun2.xml and the gun5.xml. Could open this. We see it looks a bit different from what we're used to seeing, but we just need to rearrange this. See, it comes out clear. So after restructuring that, we have this. So see how it comes out exactly like the data set we have from the Pascal VOC. So with this, we've seen how we are able to generate our own data set. So you can feel free when you have a project to generate this and then training your models without changing much of your code, because basically it's going to be the same principle every time, since your data set is going to look the same as this, or the same as the Pascal VOC data set which you're already used to working with. Now that we've generated this XML, and we have the two images, what we'll do is we come and copy these images, like this gun1 and this gun2 and gun5. We could copy this and then put it in this folder where we have all the other images for the Pascal VOC data set. Yeah, we had 26,000 items, so now we add this and we have now this. So we now collect this XMLs, and then in this folder where we have this, we add this. So that's it. In this practical section, we shall see how to prepare our data. We start by importing these packages, and then we get into this utils class. This utils class is actually going to be useful helping us pre-process the XML files and extracting the bounding boxes and classes, and then generating the output, which is of dimension 7 by 7 by 27, and that's because we've chosen a split size of 7, and we've chosen the number of boxes to be 1, where there are 22 classes. So now consider this sample XML file. Coming back to the preprocessed XML, recall that we have the element tree. This is element tree which we shall use to extract information from these XML files. We have the size tree, which is basically from this. So we have this size tree, which is this, and which permits us obtain the width, the height, and the depth. So that's how we find the height. So we use the function find. So we have size tree dot find height, size tree dot find width. We convert that to floats. So we have the height and the width just from this. Then we have the object tree, which we shall find from all the objects. So we know that here we just have one size, so we just find size. And here we have this object tree, which is actually gotten by finding all the objects, or by going through each and every one of these objects. So like in this case, for example, we have this one object. We just have one object in this example, so that's it. We have just this one object. Now there's also these parts that we could take off because we're not going to use them. So let's do this. That's fine. And there we go, we have this object. So in this case, for example, we have this object that we shall get, and then for the bounding box in the object tree that iter, the iter will permit us get the children. So we shall get the child bound box, this child. So this is what's important for us. Recall that this is important as a class, and then this as a bounding boxes. So we shall get this bounding box, and then we shall obtain the x mean by finding the x mean, and then we shall divide by the width. Then for the y mean, we shall divide by the height. The x max, we shall divide by the width. The y max, we shall divide by the height. So that's how we obtain the x mean, y mean, x max, y max. Now obviously we are doing this for the purpose of standardization, and we shall see shortly in the generate output why this operation is useful. Now once we're done with this, we could break out, and then we could extract the class. So we find a name, and then we get the text. So basically that's it. Then we have the bounding box, which we are defined here, which now is given by this x mean, y mean, x max, y max, and then the class name. Now we just include this class name, this bounding box, but we shall see how we will get just this first 4, and then we shall get also the class name later on. So after doing this, we add this to all the bounding boxes. Reason being that if we have many objects, we shall have many bounding boxes or many different bounding boxes. So we shall just append this to this list bounding boxes. And then after this, we return the bounding boxes. So for each image, we return the bounding boxes and the classes. So that's how we preprocess this XML file right here using the element3 package. Now, once we're done with this, we can now look at the generate output. With the generate output, once we get the bounding boxes, so suppose we have this image, we have this classes, we declare this utils object, and then we could obtain the bounding box by applying utils.preprocess.xml. Now notice that we have the same image, that's this image, and its corresponding XML. So once we have this, we now run it, and then we could print out the bounding boxes, and that's what we get. We have this two-dimensional list where this first one gives us the first bounding box, the class, and this other one the first bounding box, and then the class. So this is exactly what gets into this generate output we have right here. Now once we have this generate output, we now try to create our output level, or we try to initialize our output level, where we have output level being this numpy.zeros of split size by length of classes plus 5 times number of boxes. Obviously this is going to give us 7 by 7 by 27 output tensor. Now we shall work for each and every box in the bounding boxes. So like we have this bounding boxes, we shall go for this first box right here. For this box, what we shall do is we shall collect the x mean, y mean, x max, y max, obviously, and then we shall generate the centers. Now if we come back to what we had done previously, where we had this midpoints, we took off some parts actually. Let's do this like this. Now we had the midpoint calculated from the pixels, that's from the pixel values. Now note that before those values get into this function, they have already been divided by 500, so this operation has been done already before. So that's exactly what we do, and when it gets to this, we obtain the midpoint with values which have already been divided by the width and the height respectively. Then next is we get the width and then the height, that's the difference between x max and x mean, the difference between y max and y mean. So since this has already been divided by 500, no need redividing again. This way, or dividing by 500 and or dividing by the width and the height that was in this, no need redividing again right here. So that's it. Next thing is we're trying to get this x center with respect to the split side or respect to the grid cell. So in that sense, what we do is we get this x center multiplied by the split size and then subtract by I. The value of I is like the value of the whole number before the decimal. So if after computing this we obtain a value like say 3.18, and then here we obtain a value like say 0.49, what happens is since we are converting this to an integer, what we do is we obtain this 3, and then from here we obtain a 0. And then what happens is, since this is 3.18 minus 3 gives us 0.18, and then here 0.49 minus 0 gives us 0.49. So that's how we get the x center cell and y center cell. So now that we have this, we're working only with this these two boxes actually. Now that we have this, we're trying to set in the values as required. So we are having this output level, this is the ith value, the jth value, and then we're picking up the value at 26. Now this value at 26 happens to be this one here, so it's a confidence score. Now recall that we have 22 plus 5, 27 values, and since we're starting from 0, we end up at the 26th position right here, from 0 to 26. So what we're doing here is, if that value is already 0, or rather if that value is 0, that is if the value is not 1, what we do now is we set it to 1. So as you could see, the values ij 22 to 27, we have this value set at 1. Now at the 22nd position, we have x center cell, y center cell, x width, y height, and then this is for the classes. So this is for the bounding box and the confidence score, and then this is for the classes. So we've selected I, we've selected J, and now we're about to pick out the specific class we belong to and set it to be 1, while the others are at 0. Now the way this is done is we've collected this class. These are the classes we've got. Let's change this. Is actually gone. So we've collected this class, or rather these classes, and then we get into this and then find the position of a given class. So if we have, like in this case where we have dog, we just have to come and find this position. So let me subtract. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're at the 12th position. So this is 12th position right here. So this means that at this 12th position, we are going to put the value 1, and that's the role of this get position function right here. Where with the get position function, we just go through the classes dictionary or classes list we have right here, and then we look for that position where this dog is going to match with whatever value we have. So that's how we get this, and then we feed this in. So let's run this and do a simple test. Take this off, run it again. Okay, now we could run this, and then we generate the output. So we call y generate output of the bounding boxes. So that's it. Now instead of printing this, let's run this. This is not defined. Okay, that's utils dot this. Okay, so now we could print out y that shape first. So we have that, that's normal. Then we could go ahead to find those positions where we have this bounding boxes. And to get those positions, we could simply print out I and J right here. We have I, J. So let's print this out, run it. So we have these positions 2, 4, 3, 3. And there we go. So right here, what we could do now is we have the 2, we have 4, and then we print out the value. This shows us how we select a particular class, that is 1, 2, 3, 4, 5, 6, 6 times 2, 12, 13. So we had a 13 class. This actually was the 13 class if you count from this. This is 13 class, so this matches with dog. And then after we start with the x center, y center, width, and then height, and then finally the confidence score. So basically that's how we create this output. Now if we do this for 3, see we have something similar, but this time around we have a person, so it's gonna be a different class. Now if we try another random value, let's say 3, 5, we see we have all values as zeros. So that's how we create or prepare our output. Now if we recall, in the data set or in the folder where we have our data set, our training data, we have about 26,000 different elements. Now those 26,000 different elements could be 100,000 or even millions of different images and their annotations, which we could use to train our model. And so to be able to work with this kind of huge data sets without exceeding the memory limits, we can use the TensorFlow's data generators. So here we define this class data generator, which inherits from TensorFlow.keras.utils.sequence. Now what goes in here is we have this our inputs, and then with the get item we are able to get a certain number of items at a time. So this is what is loaded in memory and treated at a given time. So with that, we now have this get item, and then we call the data generation function separately in the get item function. So with this, we have this data generation, which is practically what we had seen previously in here, where we just have where in this case we have many more items to work with, but here we just had this single item where we had the image and its XML or its corresponding annotation. So with this, we have the data generation, we have the get item, which permits us using the ID to obtain the data or to obtain the inputs and the outputs, that's X and Y. And then we have this len. Now this len method permits us to know the number of times we shall iterate over this get item. So suppose we have a batch size of 1. In that case, we shall have a len of train image. So in that case, we shall have around 26,000 as value here. So if we have 26,000 values, it means we are going to pass in, or we are going to get into this data generation 26,000 different times. Now, if the batch size is, say for example, 2,600, so if we have a batch size of 2,600, then it means we are going to get into this only 10 times, since each time we treat batches of 2,600, then for 26,000 different items we shall get into that only 10 times, since this divided by this gives us 10. So that's actually the rule of this, and then we do this to ensure that we are actually working with an integer. So that's it for the len function. Take this off. Now we get into the get item. We have this id which is in this. Now you should know that this class has this 2 methods as some sort of template, so we'll always have this 2 methods in here, whereas this one is just a method, or it's just something additional we are adding to this get item. So we could always define all this in this, but we want to actually separate this so you see it clearer. Now once this is understood, it means if we have, for example, an id or 1, let's suppose the batch size is 1. So if you have an id of 1, what happens, we get into this, we take in this data generation, takes in the value 1. We had initialized, or we had defined our class data generator, and then we have the init function which takes in now all this, or where we declare all this object variables. And then once we get into this, once we get into this data generator, we define x takes in batch size. So for now it's 1, 224 by 224 by 3. Then y is this. Now we could always change this. So since we have defined the split size to be this, we'll change this to self dot split size, and we'll repeat this. So there we go. And then right here we could always modify this to have self dot number of boxes times 5. So we have that plus the len of self dot classes. So yeah, we're gonna have 22. So that's just fine. So once we have had this, say that's okay. Now once we've had this, we have our y. Then we get into this for loop. What goes on this for loop is quite simple. Since we've seen this already, and we're just trying to repeat what we just did right here. Now let's understand this for ij in enumerate and this term. Let's start by printing out this term. We have this. Let's put it this way. Let's define it to be a. So right here we'll define this to be a. Now let's specify idx. That's the id. Let's say the id is 0. So we have this. Now let's choose a batch size of, say, 32. If a batch size of 32, we have this batch size of 32. That's fine. So with this we could now print out a. So we have that as a. So we see clearly how this is done. So when the id is 0, we have this value of a, or this list, which takes in values from 0 to the batch size. Now once we move to 1, you'll notice that, or let's take this to be 0, and let's just simply repeat this. So we shall have for idx in range, let's say 3. Then we have this, and we'll have that. So we have had this. Now for idx in range 3, we've had this. So we see we'll go from 0 to 31, then from 32 to 63, then from 64 to 95. So we see clearly that we just go into the whole data set. So our data set has, for example, 96 elements. Then this is a way we can go through all this different elements, considering that we are working with a batch size of 32. So we have 32 elements, and 32 elements. Now coming back to this, if we let's take this back, let's maintain this. So we have idx, let's say idx equals 1, for example. So coming back to this now, if we say for ij in enumerate a, so enumerating through this, let's print out ij. So we could print out ij, and we have that. So we see that the I, obviously, if you understand, you should understand the enumerate function. What we're doing is we're going to go, or the I right here is going to consider that all these values are being incremented as we go on. So we increment from 0 right up to 31. Then we're going to get for the j now, we get the actual values we have. So we have the position, and then we have the actual value. So this is the position, is actual value, position 1 actual value, position 2 actual value, and so on and so forth. So that's actually it. Now coming back to this, we see that if we have a batch size of 32, then we'll be able to treat 32 different elements at a time. Wherein if we have image, like we have defined the TensorFlow.keras or preprocessing.image.load image. So actually here we're loading an image. We have the training images file path, and then for that file path we now attach a given image. So we have the train image list, which we shall define shortly. This is the image. This is the specific image. The color mode is selected. The target size is selected. Now to create xi, what we simply do is we change this to an array. So we take this image and pass it to an array, and that's fine. So we've created xi. Now note that xi is just one of this, so it's just one element in this. So in the case where we have a batch size of 32 like this, obviously we shall go through this in this for loop 32 times. So at the end of the day, we shall have x0, x1 right up to x31, just like this. So that's the use of this I and in the enumerate, where we actually get the x0 up to x31. So with this we have that, and then for the next we define the utils. Again, we have a utils object. We specify the split size, number of boxes, classes. We obtain the bounding boxes. Now notice again here that something similar to what we had done right here. We have the train maps. We have the specific XML file, which is with the J, so you could see that clearly. Specific XML file, like this is the exact value. See, as you could have that clearly from there. And then we now generate yi. So with that again, we generate the output. And then since we're looping this, as we have said, we're going to go through this 32 different times. And so with that, we create a batch size of, or we create an output y with 32 7 by 7 by 27 tensors. So once that is done, we return x and y, and that's how we generate our data set, wherein only this batch or only a specific batch is loaded in memory, and then we keep on loading the others as we continue with training. So we could take this off, that's fine. Then now we could define this, take this off. We have the training images. We should define, we give it the path. This is where we have all our training images. This is where we have all our training maps, that's the annotations. This is the validation images and the annotations. Then here are the classes. This is gone actually, so take this off. This is gone. Split size 7, number of boxes 1, number of epochs, could take 100 epochs. The learning rate, we could start with this as in the paper. The batch size 128, so that's fine. Okay, so once this is done, we could run this and then run this. Then finally, what's left for us to do is just to simply call this or create the generator actually. So right here we have the train generator and the validation generator. So we see clearly how we get the train images and pass the train maps, split size, number of boxes, classes, the batch size defined, and everything is okay. So we could run this, and you see that we're dealing actually with a data generator, so that's fine. Now we could go to the next section.